Thanks very much, Anna, and thank you to Christoph and to Patty. That was a very interesting discussion of the form of aeronautical software, very important group within RTCA EuroK community. So this is actually one of the last panels for these this two-day summit, and we've heard a lot from many members in the software industry, in the standards development industry, and with regulators of airspace over the past 2 days. And we've learned quite a bit from each of their perspectives. I want to remind everyone at this time, if you've joined us late, that at the bottom of the screen, there's a link to the Slido that will allow you to participate in the coming polls. There are going to be several polls that we're going to have, and allow you to pose questions to the speakers. And those speakers are going to be what, for me, and in my view of this summit, is where the rubber really hits the road. Because now we're going to be hearing from two representatives from two different organizations that are pushing the boundaries of aviation technology while remaining within the swim lanes of the accepted software certification processes. And we want to know, what are the challenges that they're encountering, and how are they coping in a development environment that's very fast, it's very complex, and is very much safety of life critical. So I want to first introduce to you Oliver Reinhardt of Volocopter to present his experiences, and when he's complete, Oliver will introduce Tom Ferrell of Joby Aviation. So let me turn it over to Oliver.
Thank you very much, Al. Good morning and good afternoon also from my side, everybody. And thank you very much for having me on this panel session today and giving us the opportunity to share what actually we are doing, where we are standing, and where really the challenges are. Let me share some few thoughts, provide you some impressions, and trigger some hopefully healthy topics for our discussions later on. First of all, quick introduction, as I'm not that famous in the software segment so far. So my name is Oliver Reinhardt, and I'm the Chief Risk and Certification Officer here at Volocopter. And with this, I'm responsible for certification, for all the safety management, quality management, and some further activities. My education and background, I'm an aerospace engineer with now 25 years of experience in some different roles through various challenging aviation projects. Typically, I'm tending to go to the novel projects and to the new categories in there and in some different environments in there. So before joining Volocopter, finally, some 4 years ago, I've been a CTO at a light aircraft manufacturer, where we certified and delivered some up to 300 aircrafts per year in a total of 42 countries. So already at that stage, we were pushing the boundaries quite a bit. And since some 10 years, I'm also active in several rulemaking activities committees with the EASA, with the FAA, and I'm developing industry standards with different standards bodies. So as of today, I'm also the co-chair of the EuroK Working Group 112 on the VTOL aircraft. In a nutshell, here at Volocopter, we are targeting to become the leading urban air mobility provider right inside the mega cities around the world. Let me share a few snippets of what is possible today, what has already been achieved. Our aircraft are flying manned and unmanned since 2016. The flights shown here on this slide, they were all real and conducted with all required aviation approvals. So you see on the left, Bruchsal, our first manned flight in 2016 with a real multi-rotor aircraft, multicopter aircraft. Then Dubai, first autonomous flight within the city limits of Dubai. Las Vegas, we were flying unmanned on stage. Helsinki, that was a manned flight and integrated into an up and running international airport. Stuttgart, the next flight was in the heart of the city, in front of 12,000 spectators, really testing the public acceptance and also polling for the feedback from the public in there, how they perceive this kind of operations, this kind of vehicles in the heart of their beloved city. Singapore, manned flight along a touristic road over Marina Bay. Or Bruchsal, first flight of the cargo drone derivative. And actually this flight is since this Monday no more actual. We just didn't manage to get it in already in there. We've been flying this Monday in Paris, an unmanned flight during the Le Bourget Air Forum right in the city in Le Bourget Airport in there. Using this as a basis, we're actually now in the process of certifying a line of up to 3 aircraft variants targeted for very specific mission cases, transporting passengers or cargo in urban and suburban environments. So yes, we are here. We are no science fiction. Since 5 years, we are actively flying. If you would count our flying yoga ball in the very beginning, it would be even 10 years. But with the real aircrafts, it's since 5 years, we are up in the air and flying and showing that this is feasible, showing that this is possible. And we do the same things as the big guys. We are flying passengers. We have shown that these aircrafts fly and can be operated safely in urban environments. But careful, it's not just about the technical ability to do it. It's more about being allowed to do so, having customers and the people we fly overhead trusting and accepting us in what we are doing. It's a bit similar what we heard in one of the earlier sessions in there. I mean, aviation today, what is it? It's the outcome of many painful learnings. Starting from the wild, wild west of aviation, technologies were developed, taken into service, experience was collected. Failures in aviation were hurting passengers and uninvolved people on the ground. Increasing amounts of accidents did lead finally to implementation of our regulating authorities. Shortfalls were compensated by establishing case-specific requirements. How should we, as the newcomers, be treated in this environment? At this point, can we please launch our poll number 9, where I'm asking you for your honest opinion. How should the issues of risk be balanced against the introduction of new technology and new entrants into the aviation? We will look later at the results of the polls. Legacy aviation today is governed by many rule books that tell us, when you do it this way, you will likely be safe and you will be ready to get a certificate. But keep in mind, that's the output and the outcome of painful learning with dedicated classes of products. Now, here comes us showing up with something completely new. Entering an airline is a natural thing for all of us. We just know that we can expect to safely arrive at our destination. We do not think about accidents, so it's naturally safe for us. Those aircrafts we are using today are a combination of an airframe, dedicated systems, redundant functionalities, functional separations. You can lose a lot on a legacy aircraft, and you still can safely land it. Now take our new eVTOLs. They are different in being essentially one big flying computer. And now we come here. And as we are different, we think we can outsmart legacy aviation by doing it like automotive or consumer products industry, like they are doing it today. Really? Are we sure about that? I mean, remember the pictures of electric cars burning on a highway? Or how often do you need to reboot your mobile device just because it's hung up? I think we all would love to perform like the consumer product industry. Take an example, Apple iPhones. It came in pretty disruptive, setting completely new standards. It was changing the industry. It was launching the new product category of true smartphones. This product series has created 24 models in just 14 years. They are delivered worldwide. They are delivered in vast numbers. They are always up-to-date technology. They are setting new standards. How do they do this? There are many, many aspects behind this. One prominent element behind this is the way how the development actually is conducted. Agile is one of the buzzwords used in this industry. Scrum, Kanban, methods, they are all methods applied by Agile. Key is to accept that there is a high volatility in the environment, which requires the use of flexible processes that allow for ambiguities for quite some time along the development roadmap, and to take decisions on the next steps only when it's really time to decide. And it also needs to allow to decide which features will be included when going to the market and which not at a rather late stage, depending on their readiness levels. So back to aviation. What's happening in aviation? I picked just one random example, the Airbus A320 series. This aircraft family is covering A318, 19, 20, 21. It was launched 33 years ago and has gone basically through 6 models since then. Just remember back, the iPhone started 14 years ago, and has been successful with 21 models. So what's driving our development in aviation? Just remember back to the earlier slides. Aviation is a huge bundle of lessons learned, standards applied, quality management in design, clear, structured approaches. We define what we need at the beginning of the process. We want to avoid surprises. At least we try to. In some cases we are lucky, in some cases not. We walk the V model, the famous V model in there. We do our reviews. We follow one big cycle through this V model from the product idea towards ultimately the product certification. At this point, let's please switch over also to our next poll, the poll number 10, where I would like to hear about your experiences. Have you tried modern development approaches like agile development, use of open source codes, different compiler choices, other non-traditional software approaches? And how did this affect your certification efforts? Again, we will look later into the results and discuss a bit the outcomes, what we are seeing there. So to the bottom line, what do we, the new entrants to this field, see? And where do we see our chances? And essentially everything I'm speaking of here, to my view, is valid, whether we speak of one piece of equipment or whether we speak of just a completely new autonomous aerial vehicle as we are developing right now. Aviation today is incredibly safe. We know it, we trust it, we ensure it by a lot of preventive strategies. I touched on the development process elements, as we know from our famous standards. But there's also the quality management, there is safety management behind that. We are new to the game, but we will not be given the same learning curve opportunity as legacy aviation had from the wild old days onwards. We are expected to start where the bar is today, at the highest level of safety. But there is still significant room for improvement. Being smart does not come from being smart in just one single aspect. It comes from being smart in the overall picture. The architecture of our products is different. Our functionalities are different. Our systems are different. We can treat them by the old methods, for sure. And that gives us a safe way to come to a certifiable product. But being open to new approaches can offer quite some chances for these kind of new vehicles. Agility, it's not a buzzword, even if it's often perceived in the meantime as something like this. Agility has many facets, and it does not come off a cooking book. It doesn't come overnight as well. To become smart and agile, you must carefully find your way into it. Then it may pay off. At least that's our experience in here. And forget about one misperception, please. Being agile does not mean you cannot have a plan. That goes well together. So it's up to us. What are we making out of our opportunities? And with this, thank you for your attention. And I would like to hand over now to my fellow panelist from Joby Aviation, Tom Ferrell. Tom, floor is yours.
Thank you, Oliver. It's great to be here, and thanks to EuroK and RTCA for the opportunity to share some thoughts with all of you today. As Oliver said, my name is Tom Ferrell. I lead the development assurance activities at Joby. Prior to joining Joby, I have spent time at Boeing, Iridium, and just prior, 19 years running my own consulting company, where I really did focus on a lot of new and novel technologies, which is actually how I came in contact with Joby. Just as a matter of background, I am an FADR. I've been one for 30 plus years now at this point. And I was a part of Special Committee 167 that wrote DO 178B, SC 190 that then provided a ground approach and interpretation, and most recently SC 205. I'm now participating in SC 240, although I will say my day job has limited my ability to contribute to that effort. Before I get into the slides, I'd like to ask for the first poll for this last session, poll 11. And this is really asking you to comment on your DO 178 experience. And as Oliver said, We're going to take a look at the results of both his polls and the two polls in this session when we get into our Q&A at the end and discussion. So with that, we'll go ahead and move on to the slides. I'm not going to spend a lot of time introducing Joby. We're obviously a new company, although maybe not as new as many people think, because we kind of stayed in stealth mode for quite a while. We've actually been around for 13 years now. We've been flying full-scale aircraft since early in 2017, and we are really focused on the urban air mobility space through a pretty novel vertically integrated approach. So if you want to know a little bit more about our company, you can find information on the web. So before we get launched into the details, which is maybe a little bit more technical than some of the other sessions, I just want to say I had the opportunity to host Terry and Al from RTCA at Joby almost 2 years ago. And we had a lot of wide-ranging discussions during their visit. A lot of it centered on how you marry the Silicon Valley mindset of move fast and break things to get to a viable product and a bankable product with the much more methodical approach typical in aerospace development. This involved talking about the shift to performance-based rules, the safety continuum, more of a risk-based approach, and how you put all of that in the context of new and novel technology like electric aircraft and vertical takeoff and landing aircraft. We also talked a lot about the velocity of development, and that's really where I would like to focus the discussion going forward. I need to figure out why slides are not proceeding. Here we go. So I do want to make sure and really emphasize something that Oliver introduced. We have all eyes on us, right? You know, how we are approaching safety. We have to start with a high bar right at the beginning. So the FAA, EASA, and everyone is really scrutinizing heavily what we are doing. And I want to make sure that it's clear that, you know, even though I'm going to be serving as a bit of a provocateur in my remarks, you know, our company is just as committed as Volocopter and all of the other new entrants to hitting that safety bar. So we are very much committed to full compliance. And as just as a an example of that, we've brought in a strong development team with a certification team with over 1,400 years of combined certification experience. So my remarks today are really intended as a thought exercise to see where and how we can bring innovation of Silicon Valley to bear on the topic of development assurance. Those of you who have worked with me in industry committees before should recognize some of these themes I want to touch on. They're not new, but I would say they are more urgent than ever, given the complexity of modern development. I will note on a personal note, I was in a meeting earlier this week and I had to defend an element of DO 178, to which someone called me a DO 178 fanboy. And, you know, Hecky mentioned earlier today that we have to cherish what we've developed and achieved with our software guidelines. But as Patrick Kai of EASA said yesterday, just because something has served us well does not mean it shouldn't evolve to meet modern needs. And that's really where I want to focus going forward. So before we launch off into what I would suggest maybe some opportunities, let's talk about some fundamental truisms that I hope we can all agree on. First, a few thoughts on software safety. A few would argue that having a documented, repeatable process is likely to lead to higher quality. Similarly, trying to achieve any attribute for a design, if that attribute was not necessarily considered from the start, will be a hit or miss at best. And finally, without a system for software to reside in and operate on, it's impossible to assess whether the software achieves its intended purpose, especially a safety-related one. But Oliver was really right in his remarks. We are building flying computers with these modern aircraft. Oops, sorry, wrong button. So if we turn our attention to the development of software, a few more items are worth noting. First, only the simplest of software can be built with just a compiler and linker. Large-scale development requires managed code repositories, tools for build management, and a means to both manage new feature introduction and defect tracking. Our tools have evolved over time to incorporate sophisticated linting tools, affording a level of static code analysis not previously available, and even the ability to quickly develop test harnesses where much of the heavy lifting of creating a test framework can be rapidly established. Development teams have become adept at organizing their work around user stories and breaking their work into manageable chunks to allow for functionality to be quickly demonstrated. Most of these advances involve some level of abstraction, with much of the lower level machinations hidden from the developer, who is freed to focus on solving the application level problem. Now, when I circulated both these slides and notes for review, I was challenged on the very last bullet you see on this slide, that agile development is a well-proven development methodology. And most of that challenge came from those of us who have worked in aerospace a long time. They're like, yeah, we still don't believe it. I would tell you that there are many ways to implement agile. Many references I heard in the sessions yesterday suggest a very rigid application of the Agile Manifesto. This is problematic for safety critical development, no question. But Agile is not a one-size-fits-all. As Patrick Kai also noted yesterday, we have DAL-A projects that have successfully used Agile. It can be employed in a lot of ways, including as a project management tool. So when all you have is a hammer, DO-178C and its predecessors have been with us for over 30 years. The overall intent is crystal clear. Take a set of validated system requirements and implement the software to meet them. Accomplished layer verification and with the goal of eliminating all design errors through the application of defined, repeatable development and verification processes. Once you've done that, leave it alone. If you have to touch it, perform a detailed change impact analysis, rinse, repeat, and do it all over again, often to the tune of 18 to 24 months, just to implement relatively modest changes. Hopefully most everyone attending this symposium knows that this is not how modern software development works outside of our domain. Most industries push software updates frequently as problems are identified and subsequently corrected, or as new features are implemented. Probably doesn't make sense to do this for an automatic flight control system, or does it? What if this is combined with the concept of resilience? Those of you who keep up with system safety may know this as the concept of safety 2, as postulated by Eric Holnagel and others. What if we really embrace the concept of error tolerance? Note, I'm saying error tolerance and not fault tolerance at the software level. This term appears in AC 251309, both the release version and the Arsenal version that's been used most recently on the 787 and the A380. It appears once in that document and is not discussed in any detail, nor is it expanded on in ARP 4754A, DO-178C, or DO-254. As an example, consider the Joby aircraft design that we are currently working on incorporates layered redundancy, including 6 props driven by 12 motors, 4 ailerons, and 6 rudder vaders, all powered by 4 cross-connected batteries and all woven together with a multi-node redundant network. Civil aviation has not seen this level of redundancy previously, and it at least raises the opportunity for revisiting traditional development assurance approaches. The presence of layered redundancy in a design should allow for greater error tolerance. Couple this with sophisticated and persistent data collection, along with rapid response through more frequent software updates, and we are looking at software and systems that can be steadily improved while ensuring a high degree of resilience across a fleet of vehicles. But what is this heresy of which you speak? DO-178 allows for iterative, spiral, and even agile development with some amount of creative application. Unfortunately, the way it often is interpreted and applied creates barriers, both real and perceived, in being able to apply such life cycles. Agile works best when paired with continuous integration and continuous delivery, often referred to as DevOps, including downstream verification built into that release cycle. While it has the benefit of accelerating releases, its real value is in helping to isolate introduced errors and faster mean time to resolution for those errors. Within SC 205, we opted to keep Section 7, configuration management, essentially unchanged from DO 178B. So as the software engineering discipline has matured and we have gone from release cycles measured in months to release cycles measured in hours, the types of CM records and activities remain unchanged. In general, modern CM repositories can be used to demonstrate all the same compliance data that DO 178 ED12 requires, but the issue here is one of volume and usefulness in supporting compliance demonstration. What really matters is a broader mapping of change between fielded software versions rather than all the churn in between. Perhaps some level of abstraction could be brought to bear here that would allow a refocus on more important aspects of ensuring software safety. Continuous integration demands a means by which new software commits can be rapidly tested, both for their own functionality, but also to detect regression. This has given rise to sophisticated ways of incorporating testing into the release flow. Between the concept of design for testability, a core aspect of Agile, and the advent of highly adaptable scripting languages such as Python, many tests can be automated as part of the release cycle. This type of testing can be difficult to map to the categories of tests called out in DO 178C, and it may not always be fully traceable. In our current paradigm, such tests must be treated as ad hoc, and in general, no certification credit can be claimed for their use. Like the universal verification methodology, or UVM, employed for integrated circuit designs, some focused attention on these approaches might open the door for better, more comprehensive testing. As there is currently no credit for such work, there is also an implied incentive away from their use, even though most other industries find them invaluable for achieving highly dependable software products. This last point of testing is a double-edged sword when it comes to DO 178C compliance, as it's often the developers of the code who are the best positioned to write both low-level and integration tests to be included in the test automation. It's also important to note that most modern software engineering textbooks suggest that a developer unit test their code before it ever leaves their desk for higher levels of integration or is being made ready for peer review. Here again, this testing is often considered ad hoc and throwaway, given the limitations that we have built in DO 178 surrounding independence. Don't get me wrong, independence and verification is important, but there are many ways to achieve it. It has been my experience that while DO 178C may allow for nuance in how this is accomplished, those overseeing its application do not. The issue of prescriptive application creates a range of challenges. Language features such as the use of standard template libraries in C++ may give rise to places where significant capabilities of the language need to be suppressed. We've always had to consider language subsets, but never one so central to how a language is designed or that compiler functions. The trade-off between the power of the abstraction that a language like C++, when implemented and used to its fullest extent to allow for more comprehensible code, is in direct conflict with enabling other aspects of compliance. With the concept of parameter data, we attempted to give a name to configuration data, but in trying to define associated processes, we have now created a host of interesting and challenging corner conditions when thinking of various approaches to calibration and rigging data. And don't even get me started on our attempts to slice and dice the tool qualification space, such that now we have had to create a dozen fast topic papers to clarify our intent. The expression of the more you squeeze, the more sand disappears between your fingers comes to mind here. The more I work in development assurance, the more I come to realize that prescription can be extremely counterproductive. I want to end this polemic circling back to another benefit of modern development, namely data. Much has been written about how reams of data are created per flight on a modern jetliner, over 0.5 terabyte for a Boeing 787. Data analytics allow the data to be examined in ways that were only a dream when DO 178B and C were being authored. Now we can recreate the entire digital history of an aircraft during a flight or 1,000 flights. In this data lies the power to demonstrate correct nominal operation and often provides much more detailed forensics when off-nominal conditions are encountered. This data allows for simulations to be more accurately refined, and it affords novel approaches to verification that simply were not envisioned when Section 6 of DO 178 was written. I know because I was a part of the subgroup that wrote it. Innovative approaches to leveraging data can directly improve the safety of our designs and implementations. We need to enable rather than impede these sorts of advances. So if any of this is resonating with you, tell us what you think. Let's pull up our last poll, poll number 12, that asks you to consider the balance between risk and the acceptance and adoption of modern approaches that I've been discussing. Again, we'll go through the results when we get to the discussion session. So I hope that I've raised an issue or two here that will resonate. None of what I have said are really UAM or AAM specific. They are universal to modern software development and the development assurance universe we find ourselves in. So earlier today in poll 5, there was a question about how we should be considering the risk-based approaches. And 65% of the participants said that we should establish a proper risk approach for all, not just something that works for new entrants or a particular new technology. That's my point here. A lot has been said about how our requirements-driven approach to approving software and system fails when confronted with neural networks, especially deep learning techniques. I would offer that this is only a small part of the challenge, given advances in modern digital system implementation. I have argued for many years that we would do well to step back and find the items that are universal in safe systems and focus our energies there, regardless of the implementation domain. The overarching properties effort has helped a lot in teasing out these aspects that should be universally sought. I know that some have argued that it goes too far and is too abstract. While that may prove to ultimately be true, it has also helped a lot in getting to the true why of what we do. Another effort, the abstraction layer work that you've heard referenced in multiple sessions, opens the possibility of acknowledging work from other domains and recognizing where, in fact, in some ways, they're approaching the same challenges we face and have other ways of solving them that we would do well to consider. In closing, I would simply offer, I think we can and must do more. Thank you very much for your time and consideration.
Well, thank you both. Those were both very enjoyable presentations. I think it's exciting to see the work that Volocopter and Joby Aviation are undertaking and how applicable to the very core of what this summit is supposed to do, which is to bring together the new entrants and the new ways of doing things and talk about the existing methodologies and standards for certifying that software and where are the gaps, where do we need to make changes, and this is just fascinating work. So I want to thank you both for that and for the poll questions that you offered, because I think it provides some real insight. I was watching the polls as they were being conducted and seeing the race between various options. So why don't we pull up the results for poll number 9, Oliver's first poll, and see what was said there. So how should the issue of risk be balanced against the introduction of new technology and new entrants? It looks like there's a two-way tie almost between it's time to establish a proper risk-based approach commensurate to the overall risk exposure. So looking at some type of risk-based approach, and then there's the risk-based approach should be applied to new entrant applicants with new technologies, and leave the existing transport category aircraft, and they've gone and tied up right there. Leave the existing structures alone, which is very, very interesting take. So let me ask a few questions about that. given this risk-based approach, Oliver, what makes these vehicles so novel that we might need to review the applicable standards and software system hardware going forward?
Yeah, I think I touched on some of the elements previously in the slides in there. I mean, classically on the aircrafts, we have very well structured and separated systems with our interfaces, but each one holding its own functionality that has started to develop further, but it's essentially where we come from. We are now highly integrated. Functional separation in the risk assessment, it plainly doesn't work anymore. And this may raise criticalities of systems, hardware, and software rapidly to highest risk classes. Proper addressing how this situation can be handled efficiently, that would be very helpful. That's one aspect. Another aspect, the unmanned and autonomous vehicles will rapidly offload functionalities that you classically have on board of the aircraft down to the ground-based stations or even elsewhere. How do the standards apply to the ground-based systems? To which part of the system? How do we handle situations with varying ground stations dealing with multiple aircrafts where criticalities of different functionalities are seen in a different way? How to integrate this? I mean, that's one of the true novelties when going autonomous, when going automated, when we are not having the pilots anymore on board of the aircraft, latest by then. And then thirdly, also with the possibilities of having some ground-based support of these vehicles. Tom mentioned before the wish, the desire to really rapidly deploy new features. And I'm fully in agreement with what Tom presented in there. I mean, that goes one step further. When we have the ground-based support in there, we might even more rapidly deploy new features to the fleet in service. Just compare what you have in your cars today when you get over-the-air software updates, when you rapidly can add a new feature to the product that you're having and using because right now you need it. Considering the aspects before, how can this be handled properly? And I think that's all questions and challenges and needs where this novelty of our vehicles is asking for new safety thinking, for new approach thinking. How can we go commensurate into this approach in here? And from that end, I'm happy to see that the poll at least shows, yes, we all need to go into that commensurate thinking in there. And that's also my true belief in there. That was my true belief when being on the Part 23 rulemaking committee in there, where we have discussed this at length in there, how to really make this happen in there. And yeah, I find it interesting to see from the poll now the difference between, well, do we allow this possibility only to the newcomers, or do we allow it to everybody in there? And my sincere feeling is we really should allow it to everybody in there, as otherwise we might run into the pitfall having this novel approach to the new players, to the new kids on the block in there. And with the new systems, yes, inevitably statistics will play against us. We will have some accidents. And all too soon, it might be attributed plainly to, we have done this novel approach in there. So better really map this to the broader range of the systems that we are having, allowing it in the similar logic, in the similar way to all of them. That helps to really level off and separate if something happens, whether it's really attributed to this, which I'm clearly convinced it will not be attributed to this kind of approach.
Certainly a lot of aspects are new to this technology and to this movement, the UAM-AAM movement. I'm reminded of a lecture a while ago that talked about elevators, and elevators in the early 20th century having elevator operators on it. And when they first transitioned to the fully autonomous elevator, where you walked in and you push a button, the things that we take for granted today, people were terrified of them. They would not use them. They would take the stairs because they were afraid the automation was going to fail. And I imagine there's going to be a bit of a trust issue going forward here too, with people wanting to wait and see how all this falls out before they begin to embrace it the way they embraced Part 121 transport category flying today. I want to jump over to a couple of Tom's polls too. I'm gonna stagger back and forth between Oliver's polls and Tom's polls, make sure that we give good coverage. So could we bring up the results for poll number 11 that Tom called for, and take a look at what the results of that one were. And the question was, have you or your company experienced challenges using DO-178 or ED-12 for software certification? I think there's a resounding question here. A couple of observations. Number one, I'm glad to see that there's no one out there that felt that there was always problematic, that DO-178 and ED-12 were going to cause problems every time they used it. And the case dependent, partially okay, partially problematic, that's kind of a good answer. It's saying that that we want the thing to be a little bit flexible, a little bit more flexible than it is right now, but it's also useful in its current form in some of the case. So Tom, could you give me a little thoughts on what you see in this poll?
Yeah, I think this is spot on, and it agrees with the poll that was run in yesterday's session where we had 71% really saying that, you know, the core was pretty good. But there were some problems in some areas. And I tried to highlight a few of those in my remarks. You know, DO-178 has served us well, but if I might build on the question from Oliver's poll, a lot of the new technology that we are looking at for UAM and even UAS, I would say, are really what I would consider to be system level. They are not down in how you actually implement the software, with the glaring exception of artificial intelligence and machine learning, where it's very difficult to trace requirements down to your linear equations, right? The real focus of what I was trying to point out and what I think these poll results show is that it's where you get the intersection of modern software development with what is essentially a core document in DO-178 and ED-12 that was written late 70s, early 80s, because that core document really did not change significantly from DO-178B to DO-178C. And I see such a huge bias toward this has always worked. All you new guys who are trying to bring this modern software stuff, whether it's agile, continuous integration, high levels of test automation into this, you still need to do exactly what we've always been doing in the same way and provide the same exact data. And I think we owe it to the industry, again, not just for UAM, but as Oliver just reiterated, for everyone to step back and say there has been 30 years of software advancement in how we generate error-free software. And we need to get this new thinking, new blood into a new special committee working group that can really look at the fundamental principles. This is why I'm still a firm believer in overarching properties, because it gets to that core of why, and bring that forward and say, okay, if I want to do continuous integration, and I think we're a ways away from over-the-air software updates, but if I could just get from, you know, recertifying a software load every 6 months, from the current 18 to 24 months, that would be a huge win. Even the FAA has commented in meetings I've been in that they know applicants have held safety improvements because they have a prior certification. The FAA has already ruled to say their system is safe, and they know it could be safer if they cut in a change, but everything is stacked against them to cut that change in terms of a cost and resources to bear to recertify. That's not right.
It's certainly a provocative thought, and I'm grateful that you're bringing it up here, because these are the exact kind of things that we want to address in this very summit. We're coming up on about 8.5 minutes of available time, so I want to make sure that we get results from all of the polls. Could we bring up the results of poll number 10, please, which was Oliver's second poll? And have you tried modern development approaches, agile, open source, compiler choice, other non-traditional software approaches, and how did it affect your certification efforts? Seems to be that many people have tried various distinct changes, and there have been cases where it has been beneficial. That's an interesting result. Not always a silver bullet, but certainly offering some distinct advantages. So, Oliver, what do you think of the results of this poll?
First of all, I think this result is really encouraging. I mean, the percentage of 9% basically saying only that we tried it and didn't serve us anything. I mean, that is a really low number. So that means those who have really tried it, they found some fit in it. And I see this really encouraging and confirming the thoughts in there. And after hearing also what Tom presented before, I think Tom and we are in pretty much violent agreement in there in what the potentials are, and especially how to approach it and how to go in there. And yes, I mean, Tom, you also mentioned it before. It's about, don't implement it from the rule book. Don't implement it by the Agile Manifesto. Really look at it, inspect it, find out what are the elements that really are beneficial for your specific case, for your specific processes, and then rebuild those elements and those methodologies in the way that it really serves the purpose. And with this, that would be my reading now also for those who have really received some benefits out of this, that probably was part of their success case in there. So I see this really encouraging in there. And to build upon what Tom also mentioned earlier in there, I think what we see today in DO 178C or E12C, it's not really contradicting this modern approaches, but it has been implemented over the past years or since it's existing in there in a different way. So the mindset and the experience level when reading it is along the classical ways. So if you're looking forward and if you're forward oriented, and also reiterating what you mentioned before from the quote from Patrick Key in there, yes, DAL-A projects have been implemented using Agile successfully in there. So yes, it's possible, but we must overcome the mental hurdle for everybody involved to also see that it's possible, to overcome the past experience that we are having. And maybe that is really also the trigger in how we need to further develop the standards in that respect in there. Reading them hard by the lines, the outcome of an investigation might be, we don't need to change anything. Technically, it's possible in there, but we need to overcome the mental barriers in there. And for that, I think, yes, exactly, it makes sense to really further develop them in that respect so that this openness gets visible to everybody. And I mean, we are dealing with many authorities around the world also in there. In this summit, we were speaking with the FAA and with the EASA, and we all know that those are authorities that are really forward-looking into this. But from my past with the 42 different authorities and countries where we delivered the aircrafts, there are many that are still very narrowly boxed in their existing thinking from legacy aviation. We've always done it this way. We continue to do it this way. Those we also need to get to see the possibilities and to understand it. Maybe that's the further key to develop it. And I would strongly encourage those who have said, no, we haven't tried it so far. Give it a try. Identify a small project that you can properly manage. Find somebody who has done it before to get you coaching into this. And make sure that you're not just blindly believing in your in this person that is coaching you in there, in what they have done in there. Build your own picture, map it to your own experience, to your own projects, make it yours and implement it in that way. And then you probably will also see the benefits out of that.
Certainly some good advice to get out there and attempt to use some of these newer features of the software development process and see how they benefit your development environment. So that's great advice. Coming up on some time here, getting a little short. So why don't we pull up the last poll number 12, Tom's question, and how advanced shall we allow ourselves to be in the future considering our software development processes? Looks like a pretty clear majority saying that we need to carefully investigate the effects of modern approach, run test results, carefully introduce modern elements, and when proven practicable, roll them out. So maybe we haven't reached our full potential here and getting to the audience and saying, hey, let's look at these new things and let's try some new things. We certainly want to be safe, and the second most popular option is a risk-based approach to allow for agile approaches and lower DAO levels that could possibly benefit from that. Is there more that we can be doing, Tom? Why don't you comment on these results and possibly on things that we can be doing to help convince the industry to push the envelope and the boundaries just a little bit more, and the regulators, actually?
I think an awful lot of being able to make use of modern development approaches, agile, continuous integration, very, very high levels of test automation, is to build an understanding of what these technologies bring to the table. I would offer that we probably have not done a good job in the past of applying Stephen Covey's habit of seek first to understand before being understood. It's been very interesting. Joby is relatively new, right? So not only are we creating a new vehicle, we're creating a new company. And I mentioned that we brought in a lot of expertise from aerospace, and it's been interesting to watch the dynamic between the folks who have built very successful products in Silicon Valley and those who have a long history of delivering and certifying aircraft and aircraft systems, kind of meet and on some occasions be staring across an abyss between the two parties, because they don't use common language, they don't have a common frame of reference, and it's a lot of really seriously listening to where the other parties are coming from, what they're trying to achieve, how they're trying to achieve it, why they feel that the methods that they are using are adequate and ultimately achieve the same objectives that you see in a DO 178 ED12 document. And it takes time, but when we have those discussions and we really get to the core of why is this important from a safety perspective, then we can go to the next level of saying, well, in continuous delivery of software, this is how we merge development branches. This is how we know exactly what has changed. This is how we can get back into a modern Git repository and run history reports to accomplish what DO 178 calls configuration status accounting. When you first approach this from a DO 178 perspective, and you're used to seeing a software configuration index that looks just a particular way, or problem reports just a particular way, you have to step back and understand the modern approach and say, you know what, I can achieve the same thing with these modern tools. And oh, by the way, the benefit is I can achieve it at 20% of the time. And that is just huge.
Certainly a call back to George Santayana's, those who fail to understand history are doomed to repeat it. So it's good to know why we are where we are with our certification process. Where did the rules, the current rules, evolve from, and what has changed since they came into effect that might now allow us to expand the scope and move in a different direction. So thank you both very much. We are out of time. I'm sorry we didn't get to any audience questions, but we'll certainly pass them on to our two speakers. I want to thank not only Tom and Oliver for taking time from their day to come and give these great presentations, but also thank Joby and Volocopter, two very exciting companies that are doing really cutting edge work in aviation and bringing us into the next big golden years of aviation and new technology, and thank them for the great work that they're doing and making Tom and Oliver available to us. So thank you both very much. And with that, I'm going to turn it back over to Christian for the closing remarks. So thank you very much.